Okay, 8.5 about angles of elevation and depression. No, this is not about mental illness. This is about, well, it's about mathematics, and I guess you could argue maybe that's mental illness. Okay, anyway, this is really just basically word problems involving trig. It's a lot easier than what we're doing in 8.6. It's really just a lot of vocab about real life problems that are going to lead to mostly problems about tangent. First of all, let's start with some terms. Angle of elevation and angle of depression. Both of these angles, and you can kind of tell where they are in this picture, they're measured, usually we're talking about a line of sight, some sort of diagonal kind of hypotenuse kind of looking line measured at an angle against a horizontal line. So there's horizontal lines in real life, like the horizon, or like an angle sort of parallel, a direction parallel to the ground. And if you have to look up at something, the angle of elevation is how far in degrees you have to tilt your head up to look at this object versus looking straight ahead of you. So the angle of elevation is how much your eyes kind of have to go up. So this angle that's formed at your eyes for turning your head upwards, or if you're standing up on top of something looking down at somebody, measuring again against a horizontal from your eyeballs, how much you have to turn your head downward to look down here. That's also called angle of depression. What you may notice right away about this, which seems kind of silly, is notice how these dotted horizontal lines have to be parallel. Since they're parallel, the measure of this angle of depression in this picture and the measure of this angle of elevation have to be the same because this is all AIA on these parallel lines. So angle of elevation, angle of depression are technically two different terms, but they're always equal because we're talking about AIA. All right, this is going to be a very short video. There's only a couple of things here. From the top of a lighthouse, a sailboat is sighted at an angle of depression of 4 degrees. How far from the lighthouse is the boat? So the hardest part about these might just be think about what they mean in this picture. So the lighthouse is 20 meters tall. We're talking about from the top of the lighthouse. So someone's standing here. Here's what the eyeball is. 20 meters, that's height to the ground. We're to believe that when they say height, they mean perpendicular. Someone's looking down at a sailboat. So the boat's over here. The eyeball is right here. The angle of depression is 4 degrees. So so someone standing here has to look down versus what they would be looking at if they were looking horizontal. So let's draw a horizontal. If this person is staring straight off in the distance horizontally, which seems like a dumb thing to do at the top of a lighthouse, they have to tilt their eyes downward 4 degrees to see this boat here. So if that's 4 degrees, again, we could think about this being 4 degrees because of AIA. There's nothing wrong with that. How far is the lighthouse from the boat? Okay, if this is 20 meters, this is 4 degrees. We need to find this thing. And like I was saying before, these are mostly going to be tangent problems. So this is tangent of 4 degrees equals opposite over adjacent. Solving for x, we get... Okay, we see 286.013. Now that might surprise you. Let's put this in to 2 decimal places. That's 286.01. Yeah. Come on, pen, work. There we go. 286.01, and this is meters. My picture is a little bit drastic here. I mean, I drew this quite steep for 4 degrees. 4 degrees is going to be a really skinny, long triangle. So yeah, this is 20. This is 286. That's possible. The driveway has a 15% grade. Okay, we haven't talked about grade since probably the pretest. The grade means not how well you're going to do on this test, but it's about the angle. It's another vocab term that talks about the angle at which this is setting. Grade means, like, if you see a road sign or something that says there's a 15% grade, it's kind of a number like slope. It's the angle this would be sitting at if the amount of rise divided by the amount of run, so that sounds like slope, right, is 15%. So I don't know any of the measurements of this thing at the beginning to try to figure out this angle of elevation. Again, angle of elevation will be right here for part A, what I'm looking for. I might as well just call this A. So for this angle of elevation, I'm looking for this, and I have no other numbers other than this 15%. That just means that, well, I could call this 15 and this 100. That would be 15%. That's kind of an easy way to do that. So whatever the ramp actually is, whatever its measurements actually are, it's similar to this triangle, and I'm just looking for angles, so this is fine. And guess what? It's tangent again. The tangent of angle A is opposite over adjacent. So just like you did in the pretest. Whoops, whoa, wrong thing. Inverse tangent of 15%. You could go 15 over 100. You could just say this. This is fine. That's going to be 8.53. And yes, that's degrees. So that's 8.53 degrees. That's the size of angle A. And if the driveway is 12 meters long, how much does it rise? This is sometimes hard to know what they mean by 12 meters long. So it isn't 15 and 100. It's actually, and I know the angle already. I know this angle is 8.53 degrees. When I say 12 meters long, do they mean the length of this? Like if your car was rolling up it, would it roll 12 meters? Or do they mean 12 meters like from the sky? Like 12 meters, you know, on a map sort of? Would it be 12 meters that way? I would take this to mean that the 12 meters is like in a practical sense how far your car would be rolling. So that would be along the hypotenuse. That should hopefully be made clear to you on the problems. If not, I can see that being a legal question to ask during the test, but I'll try to make it clear if I put that on the test. I'm going to say this as well. In any case, make a picture. I'll go with you on the picture. The question should be clear, though. The question is how much does it rise? So this is what I'm concerned with. So lo and behold, this one is not tangent. This one is, that's opposite, that's hypotenuse. This is sine. The sine of this number I just figured out is supposed to equal opposite over hypotenuse. So 12 times the sine of 8.53 is what I'm looking for. That's going to equal y, and that equals, now notice I already have this number in my calculator. This is nice. So 12 times the sine of that, 12 times the sine of this answer is, notice all the decimals it saves for me, 1.78. That's lovely. Okay, so it raises 1.78 meters. And we're about done. Shortest video ever. All right, two buildings are sited at the top. From atop a 200-meter tall skyscraper, building A is sited at a 35-degree angle, and building B is sited at 36. How far apart are the buildings? Well, this is assuming that everything is collinear, and that the tower is, we're kind of looking the same direction towards A and B. That should be kind of specified in the question. It could be, you know, I mean, like if I wanted to be mean, building A could be kind of this way and building B could be kind of this way. Let's not assume that. Let's assume that if this is 200 meters tall, we're looking the same direction. So angle of depression to see building A is 35, building B is 36. So think about this. Which one's farther away? If I'm going angle of depression down here and I see a certain degree, angle of depression toward the next one's going to be, you know, slightly closer. Which one of these angles has to be bigger? Well, this one is going to have to be bigger. This is 36, and this would be 35. Think about that for a second. As this point gets farther and farther away, that angle is going to be more and more acute. So that was building A was 35. Building B was 36, and the length that this question is actually asking about is this. Building A, I guess we're talking about the base of building A. Man, who wrote this question? Probably me a couple years ago. All right, that's 200. This is what I don't know. Think about what we can find and what we want to find. Right now, I could find the distance from B to C pretty easily with tangent. I could also find the distance from A to C pretty easily with tangent, and then I can just subtract them and find x. So let's call this y for now. Why not? And I'll say that was not meant to be a pun, but I think it was. All right, so the tangent of 36 is opposite over adjacent. So y is, whoops, I said y, I wrote t. Y is 200 divided by the tangent of 36. But notice this, the tangent of 35 is opposite over adjacent like this, x plus y. So x plus y is really 200 over the tangent of 35. Their difference, if I take this one minus this one, I'll get it. Oh, I could write that in one step. Oh, that sounds like something fun to do. This is 200 over the tangent of 35, because that's x plus y, minus y, and that'll give me x. So that's actually the exact answer for x. I could do that in one step on the calculator if I'm feeling good. Actually, you know what? I'll do them separately so we can get an idea of what these actually are. So, whoa, what's going on? So 200... What am I finding again? I'm finding 200 over the tangent of 36. Okay, I like doing this, making a little thing like that, the division fraction, so I know I'm doing things right here. Tangent of 36 gives me 275.28 This is y. And x is almost the same, except for I can just go up here, highlight, hit enter, change this to 35. This is 285.63. Of course, it's bigger, right? That's good. And the difference between these two is, well, it's that minus that, which I said in the first place. What? It's negative? I did this backwards. I'm sure it's positive 10. It's the 35 one minus the 36 one. Oops. Sorry, I'm not going to fix that. Fix that problem. 10.35. Okay, pen, hello. All right. I'm not going to make you watch any more than you have to. All right. Great. See you in class.